This is the issue. I think most of the time people just say pick the tool, but they don't understand what are the constraints that they're playing with. Going back to requesting limits and now, instance sizes and how a Karpenter is going to do consolidation. On the flip side, yes, you have savings. It's not common to find companies having like too frequent rotations or too frequent consolidations, which is a symptom of either being too aggressive or not really modeling the sort of the pods and requesting limits that you got in your cluster.
Welcome to Densify Talks. Thank you so much for joining us here on the podcast. My name is Brian. I am the producer of Densify Talks. We have Daniele Polencic joining us today. He is one of the lead instructors at LearnK8s, which specializes in containers and Kubernetes technologies. Daniele is a certified Kubernetes administrator by the Linux Foundation, and he has spent more than a decade training developers in e-commerce, finance, and public sector organizations, helping teams effectively implement cloud-native infrastructure. I am very excited about this conversation. Andrew and Daniele will be discussing all about LearnK8s, the organization. They'll talk about container resources, how to size containers, requests and limits, and more. They'll talk about the LearnK8s Instance Calculator, the impact of when you get things wrong, requests too high or too low, for example. Andrew and Daniele's thoughts on CPU limits, JVMs. There's a great discussion on HPA and VPA. Thoughts on Karpenter. Does it fix the request and limit problem? What about vCluster? Is it useful and able to fix the problems as well? And more with exciting new things coming. We got a lot to talk about today, so let's get into it. Here is your host, CTO, and co-founder of Densify, Andrew Hillier.
Okay, thanks, Brian, and thanks everyone for joining us. Today, we're joined by Daniele from LearnK8s. Daniele, maybe you can tell us a bit about yourself.
Hi, Andrew. Thank you very much for having me. Yes, my name is Daniele. I'm one of the instructors at LearnK8s. And what I do is basically I teach Kubernetes. I create content and I'm really passionate about teaching. So I try to share as much knowledge as I get from learning Kubernetes.
I guess a bit of a fun fact, I always find this fun. We're on almost exact opposite sides of the world right now. I'm in Toronto and you're in Singapore. Is that right?
Yes, I am. Yes, I am. 12 hours difference.
Through the miracle of modern technology, there's not even any lag. It's like you could be in the room with me. Let's start by talking about Kubernetes resources. We focus on that very heavily, optimizing requests and limits and nodes. And you do as well. You teach about it. And you actually even created an instance calculator, right? To help figure out how to size resources for new containers. Do you want to talk a bit about that?
Yeah, so this is actually an interesting story. So what happens is at LearnK8s, we deliver training, right? So we get to speak to people that are new to Kubernetes and they need to get up to speed. So sometimes they have questions that are quite common. So for example, one of those questions would be, what kind of instance sizes I should use for my nodes, or other questions could be things like, how should I size a container? What kind of request, what kind of limits should I have? And some of these questions are like, the first time you hear them, you reply, you can choose any instance you want. But the more you get asked the same questions, the more you think about it, and then the answer isn't actually really useful, right? And you think, how can I help those people to actually make better decisions? So that's basically when I started looking into finding one of those answers. I basically built a small application and I tried to find out what was the best sort of instance size for that. What I figured out is that, Kubernetes is not as simple, but there are like several layers of things that come into play. I learned about reservations, I learned about, thresholds, I learned about limits of number of pods for the nodes. And I sort of analyzing all of this data, I noticed that there were some patterns and some constraints. And figuring out the answer was really complicated. So I said, okay, what if I can just build a small spreadsheet where I can just, plot all of these charts, all of these numbers, and then find some sort of patterns or some sort of ideas on how I can make sense of it. And that was like the very first iteration of what we have right now, which is a more sort of comprehensive tool, which helps you sort of decide the instance type for your cluster.
And this is why I like talking to you, because we follow a very similar path. We're seeing the same problem out there. Of course, we focus on it more from a ongoing day two. You've got a big Kubernetes environment running and we need to watch it and constantly recommend new requests and limits. And you've approached it from kind of you're starting out, what do I do with a brand new container, which is very complimentary, I think, in my mind. Of course, if we were competitors, we probably wouldn't be talking right now. But I think it's great because it's fun to hear people talk about, because I'm always talking about this, and it's great to hear you talking about this. We find the requests and limits, the complexity is huge as far as the whole stack that you have to consider when figuring out how to set these resources. So your instance calculators, now it's an open source tool. It's available.
It is a free tool. Anyone can visit the URL, experience the calculator. The calculator was designed to explore the possibilities. So, you can open the calculator, enter the sort of details for the kind of usage for your application. And this is going to basically let you prioritize some instance types from different cloud provider. And you can also compare different instance types between the cloud providers and what kind of profile that they will give you. So it is an open source tools. I think right now we are probably the third iteration. So it started as a spreadsheet, then it moved on to some HTML and CSS, and now it's been transitioning to more sophisticated sort of analysis. I think there is something to keep in mind. I think the difference between something that you do, Andrew, and we try to do is that the calculator is a day zero sort of tool. So it's not something that, we are not competitors because there is no way we can replace a tool which analyzes the data collected inside the cluster. The calculator is designed more for exploring what kind of options you can have before you build a cluster. And then the iteration that we had during the years are because, like you said, the more you dig into requests and limits, the more you find complexity. It's a really a Pandora box.
Especially when you get into things like HPA and all these things, which we can dig into, because it's again, it's fun talking to someone that lives in this world. Yeah, and so you're day zero, we're kind of more day one or day two, and automation and things like that to make sure it stays on track. But very similar problems. So let's talk about the problems when you get this wrong, because again, I spend a lot of time doing PowerPoint talking about the horrors of what if you make your requests too big or your limits too small. And so you probably hit the exact same things. If you get these numbers wrong, what's the impact of that? This
is sort of the latest sort of iteration on the calculator. So one of the things I sort of assumed, wrongly or naively when I was building this tool was like, okay, I can help people sort of decide how big is the instance, but they sort of need to have an idea of what the requests and limits are. And my assumption at the time was, okay, you need to put request and limits, you can find the right value, and the right value is static, right? But and you're probably already smiling, Andrew.
Yep, I am.
As you might know, there is no such a thing as static requests or limits, as far as I'm concerned. And it took me quite a while to understand. And at the beginning, I thought, well, maybe I'm just not good enough to pick the request and limits. But with time, I realized that it's not about me. It's actually the application. It's very hard to actually find the right value for requests and limits. And this changes all the time. It changes with traffic, it changes with, database constraints, it changes with the application development, and there is no way you can get it right. Now I'm convinced of it. I think like all the tools that do static analysis on requests and limits are basically just right, but just a single snapshot in time, just a single moment in time. And as time progresses, then they go out of sync. This is what I started to integrating in the tool. I basically started guessing, okay, you can input requests and limits, but I'm going to give you a sort of a margin of error, like 5%, 10%, 20, 50. And I'm going to tell you what happens if your application goes 50% over the request or 50% under the request. And I'll sort of tell you, what kind of things could happen. Are you overspending? Are you underspending? And why is that happening? And I think the goal for me is try to show engineers like myself that, first of all, it is not possible to get those right. And then the second is, if you think that those are going to be right, these are the consequences that could affect you, right? You're overspending or the problem with latency and spikes. That's where I'm at the moment. I'm sure you've got way more to add on this.
Well, I think that's particularly clever because you're almost doing it's almost like a financial portfolio analysis. What does my portfolio do if the market goes up or down or volatility goes up or down? And you can kind of get a picture, because the way I view it is that it's a big system and you're optimizing the system, and there's a lot of individual elements in it. And as an app owner, I might want to set my request to my peak or something that makes sense to me because that's my app, but it's going to be running with 1,000 other services and they have to work well as a system. That's where it gets tricky, where again, the individual making the decision might make a very rational decision of how much CPU or memory their app needs. But then when they run it, because it peaks at 9 a.m. every day or something like that. But in the big pool of things, all the things together, you end up having very low utilization because they don't all peak at the same time or different effects, right? So we very much view it that you have to optimize the whole system. And it's hard for an individual to make a decision about their workload factoring in the system because they don't own the system. They don't have visibility into it. So they don't know that, if I ask for 10 CPUs, well, that just chews up 10 CPUs on the nodes, whether I'm using them or not. But from my perspective, it might make sense. So I totally hear what you're saying, because it's a portfolio of workloads that need to be optimized together. And it's very clever what you're saying about, simulating changes to understand what the impact is on my portfolio and when I'm going to have a problem. And you can do it at the kind of the day zero level, and we kind of do that constantly in the environment to say, okay, now you've got to act. And on the resource front, let's just talk about requests for a minute, because hopefully these days people don't have a misconception, but what you're paying for and how much hardware you have or how much cloud resource you have is based on your requests, not your utilization. It's what you requested. So I'm sure your calculator gives big swings in numbers depending on how wrong you are on the request.
The tool is very much organized on costs and giving you idea, because I think that's very easy to understand and sort of relate to. So it's very basic in that sense. We try to give you an estimation for the overspending or the kind of risk you would incur if you were to go with lower requests than the actual usage. Of course, the tool cannot do it, doesn't have like any pattern, right? So even when we select a range of error, that range of error is fixed. I'm sure that you experienced many times that this range can change quite a lot depending on what the application does. So I think overall, I think the tool is more on the educational side of things. But requests, I would say it is a big thing. I see it very difficult for engineers just getting started with Kubernetes to understand the implications for these requests and what kind of effect they could have on their cluster. And the other things I wanted to add is that, you mentioned the whole system. I think you're absolutely right. And one of the things that, I sort of noticed recently is that, let's say you get all the requests wrong. Some are over the top, others are like top bottom. Then overall, if the sum is still something in between, which is work for both applications, then you're fine, which is absolutely absurd, right?
But it's so true. Yeah. And you might have seen in our product, we have a visual of that. Like we actually have a histogram with red and yellow and green because of exactly that point. You can be right for the wrong reason.
Yes.
and kind of work, or you may not work. And it gets fascinating because Kubernetes only schedules based on the requests. If half your workloads are too big, oversized, and half are undersized, in a random distribution, you'll probably be okay because the oversized one helped the undersized ones. And we actually see that. But in the cases where you don't, where the scheduler puts too many undersized ones on the same node, you get out of memory kills. We actually have a measurement in our product, which is the imbalance ratio, saying the scheduler is struggling here because you're giving it random numbers, and some of the nodes are overstacked and some of the nodes are understacked. But you're absolutely right. On average, you have the right amount of capacity. It's just misallocated. And
it's a ticking bomb, right? Because it works right now, but the next deployment, the next rolling deployment might actually play the pods in a different location, and you might have the already OM. So it's just the more I unpack this, the more I try to make sense of these requests and limits and the implications, and the more I find stuff that I haven't considered the first time. And it goes back to, okay, how can I integrate back to the calculator? How do I make it simple for people to understand the implications of their choices?
It all comes back to the requests and limits. And if you're asking for the wrong stuff, everything downstream, it doesn't work very well, including Karpenter and things like that. Everything has problems if the root numbers are wrong. And again, it is very educational. Like we find now that a lot of people are aware of, the cost issues with Kubernetes, but they're less so aware of the risk issues with Kubernetes. And you can show someone an environment that has twice as much memory as it needs, yet still has nodes that are out of memory. You see that all the time. And it's just kind of this cost and risk combined. So even if you're taking a FinOps angle on it, you can't just look at the cost, because in those environments, if you start downsizing things, it makes it even worse. The out of memory kills even worse. So it is extremely complicated. But again, in our view, it all comes back to the input numbers. If they're bad, then the whole system is garbage in, garbage out all the way down.
Yeah, absolutely. But at the same time, looking from the other side, it's like getting it right is really hard work. Even with tooling, getting it right, yes, takes time. The system need to understand what's going on. The engineers need to understand how the system, and the cluster works. It looks simple from the outside. It's just a request limit, just a number. But the implications and, fixing it and maintaining it, it's really a full-time job.
For sure. And that's why, we focus quite a bit on automation. We have a lot of new automation capabilities because the way I view it, people don't want a PhD in analyzing containers. They want it to be fixed. And so, but they need the trust in the answers to know that whatever you're automating is correct, because we've seen things automate incorrect recommendations, especially around HPA where it messes it up. But once you have confidence, just flip the switch and do it. We're doing a lot of work around, we have a mutating emission controller and the new in-place resizing capabilities in Kubernetes that just says, well, once you trust the engine, don't worry about it. Just let it run itself. And I think that's really where it all needs to go, because people have other things to worry about than resources. They should be worrying about their applications.
I agree with that.
So we talked about requests quite a bit. Let's talk about limits for a second, because again, this is a very near and dear topic to my heart, because they're less about cost and more about pure risk. And let's start with CPU limits. What do you have we see different views out there on setting CPU limits. What are your thoughts on that?
Okay. This is why we get into the debate very early on. So I think there is probably no debate on memory limits. Let's put it that way. Yeah. Let me get this out of the door quickly. So I think memory limits are, best practice. We don't want memory leaks. We want to protect against memory leaks. So there is no debate if we should have memory limits. At least I haven't found one yet.
Nor have I. I think that's pretty universally understood.
For CPU limits, things are like a little bit more complex, I would say. So in general, I think most of the people give the advice of not setting CPU limits, which begs the questions of when do you use the CPU limits? Just for context, so we say we don't set CPU limits because requests are guaranteed. So if we say one CPU of request, then you're guaranteed one CPU. And all the spare capacity in CPU then can be shared among all the other services, which is great. The moment we set the limit, then the application has got a hard limit. And then if it wants to use more than that limit, it needs to be throttled. So it needs to be paused until the next quarter. So generally, we don't want this because it's going to impact the application, probably it's going to affect a latency. But I think there is always a balance. So when is that you should use CPU limits? I think sometimes, and I've seen this quite a lot, you have a cluster and you have teams and you're building a platform and you need to share this platform with different teams. And you're usually cross-charging for these resources that you're creating. So you create a namespace, and that namespace is going to have like 10 CPUs and 10 gigabytes of memory. Okay, that's quite low, but you get the idea. And I see people saying, okay, you're only allowed 10 CPUs, right? And that's basically when the limits kick in. So then the issue is that, we know that the application is going to could potentially have issues like latency and being throttled, but is it the right thing to do? I don't know. It's always a trade-off, right? What are you thinking?
Yeah, it's almost, I totally agree that if you want to have some kind of administrative control, from a technical perspective, it almost never makes sense to pre-throttle a workload when it will just throttle itself when the box is full. And what we see is it's very rare to see the CPU 100% on a node, especially on a bigger node. It's a rare occurrence. So why bother throttling yourself when the system will throttle you if you ever get up there? And so, but I totally agree that there might be administrative reasons why you'd want to have these controls. In the past, we've seen in virtual environments where software licensing can also be based on that. So I'm not sure if we come across that much because there's a lot of open source in these environments, but that's also a valid concern.
Yeah, and I think it also comes down to processes and the organization and how they repart all of these resources, right? Because if you if you don't set any CPU limits, then how will you charge back those resources, right? Then also your data collection, sort of the insights that you get from running the workloads need to be way more sophisticated than just like, I provide you with a namespace, 10 CPU, 100 gigabyte of memory. It's not just technology, but I think it's a mix of technology and business and just maturity for the organization. This is what generally the kind of experience I've got from CPU limits. So yeah, I agree with you from technical perspective, no sense. But on the other side is, can we really do it cross charge? Sometimes we can, sometimes it's more complex.
And it's also mathematically quite difficult to set a CPU limit because the enforcement at the kernel is at the 100 millisecond level, and all measurements you get out of Prometheus are scrapes, at big intervals. So it's like, I don't even know what the peak was that it hit because, so it's hazardous to kind of try and really model with high resolution the peak CPU utilization with the prevailing data collection that you see in these environments. It's just not high res enough to get it. So I think we're in agreement there. I think we see a lot of people not setting them. We do see some people setting them. And complete agreement that memory limits, absolutely, because if you don't, then you've got a noisy neighbor problem to the extreme. But if you set them too low, then you just get killed. And we see that a lot too. That's back to what we're saying about the day two problem or the static problem you were describing, that if you set a limit, then a few months later, you might be hitting that limit because you grew. And we see that all the time where just new things crop up that are hitting their limits and getting killed. And so it really requires active management. I think on the memory limit, of course, I don't see as many sort of problem as you. What I experience is more like students or engineers sharing stories with me.
the sort of feeling I get is that most of the time when someone defines requests and limits, they sort of go back to the old days of assigning, allocating resources to VMs. So they tend to over allocate quite a lot. So it's quite common for applications to receive too many CPUs or too much memory. And then the opposite. Of course, if you are under pressure to cut your spending, be frugal. I would assume people would change the limits and requests. But overall, I think the perception I've got is that these limits tend to be quite generous.
They can be. Well, and I've done almost informal studies across different environments, and we do see that absolutely oversizing is the biggest thing, especially CPU requests. Yeah. They're all way too big everywhere. I'm going to give it 4 CPUs or 2 CPUs, but I only use those when I'm busy, and I'm using no CPUs most of the time. Memory seems to be a mixed bag of too big and too small, exactly what we're talking about. Now, memory limits, though, even in environments that are wildly oversized, we see memory limit kills. It's still not in huge numbers, but they can be pretty important workloads. So we do find that the requests tend to be net oversized by quite a bit, but the limits do factor in pretty much every environment we see where there's something going on in there. And it can be like your DNS server getting killed or something nasty, right? It's that was causing this problem. I didn't know, because restarts happen all the time. So you can't just look at the restarts. So we actually have analysis that looks for what we call memory limit events, where the memory working set was in the vicinity of the limit and a restart occurred, and it kind of infers, yep, you hit your limit. Because otherwise you can't just look at restarts, because lots of stuff restart for lots of reasons. So we do see that quite a bit. It's interesting because it makes it not just a FinOps discussion. Even if you're wasting a lot of money, that usually becomes the highest priority is, we got to fix this killing activity, these out-of-memory kills. Even in a very healthy environment with lots of capacity, it can be happening.
I wonder, this is a very interesting subject. And one of the things sort of that comes to mind is that I noticed that some of these OEMs, they usually come out because whoever decided the limit basically didn't sort of understand how the underlying application works and how the underlying applications allocate this memory up front. So just to give you a concrete example, there is a specific incantation that you need to use with the JVM to allocate the memory, right? If you don't use it, of course, the heap is going to be larger than the limit, and then eventually this JVM will. So I'm just wondering, if in your experience you've seen this sort of misconfiguration triggering the OEM, or it is just legit OEMs where the application is actually growing in size. I'm just interested to know if you've seen anything like that. Well,
and so you bring up JVMs, and I know we've talked about that in the past, and it's a very good point that they're the whole MX/MS setting. They behave differently, and you got to be really careful with them to the point that you made. You can't just change your limit based on observed memory usage. You got to look at the heap size. So the challenge with that is that you don't always have the telemetry in these environments to properly set them. So we see a lot of times, for example, we just say, well, for the JVMs, don't resize the memory, just don't start trying to downsize, or maybe go up but not down. So there's different policy ways you can get around that. The ideal would be to have some JMX stats flowing everywhere that just let you do that. But you can't rely on that in an environment. Like, there's kind of a base level of data that's available in Prometheus that you can rely on, and everything else becomes a project. So the JVMs, very good topic. In general, we do find, I think, I haven't done a formal study of it, that a lot of it is due to growth.
Okay.
Again, I was looking at one yesterday with a customer where something changed behavior a week ago and it started hitting its limit. So a shift in application patterns or go live or that kind of thing, or just steady increases. Memory leaks, of course, we've seen those too. That if you see a sawtooth pattern, you've got a leak. We saw a slow one time that was leaking, but so slowly that we caught it about 3 or 4 days before it hit the roof of the whole node. It had no limit. It was about to subsume the whole node, but we kind of saw it. It was a slow enough ramp. It took about a month to get there, and luckily we caught it. So yeah, I would say that's a big one. I think if it's under configured from the start, you'll know, because the thing just won't behave right from day one. But it's really that dynamic nature of workloads changing, loads changing. The limits are probably above all else need to be watched very closely then, because they may have made sense 3 months ago, but not now. And then nobody has time to go back and revisit these things manually.
Yeah, exactly. We go back to what we were discussing before, right? It is not a static thing. It's not something that you should keep, adjust every week, but it's something that you need to adjust on an hourly basis. I don't know how frequently, you change it, but my sort of perception is that this should be like monitored very, very closely and adjusted accordingly.
Yeah, well, the way we view it is you want to go fast up and slow down. And we're actually making some nice architectural changes to our product right now in combination with this new in-place resizing capability to say, okay, if we see something nasty going on, just fix it fast. But you don't want to downsize fast. You want to look at a longer term pattern of history to say, well, I don't want to make you smaller and then month end come around and you blow up because your limit's too low. So that's kind of our mantra is the downs you want to be very careful with and look at long time frames. The ups you can do on a shorter time frame. And really, I think for a well-architected environment that's using things like HPA properly, that's the way to go. I shouldn't have to adjust things that frequently if they're horizontally scaling properly, if that makes sense. So like in a legacy, like a VMware environment or even a cloud instance, I need to size it to the high watermark of anything it's ever done. And so maybe for containers, I need to do that for the limits, but the requests can be more normal and more rational and lower, and it can horizontally scale with load. So if something's properly horizontally scaling using HPA, for example, then everything should work great. And ideally, I'm not adjusting the requests and limits every few seconds, but they're just set for the workload I'm expecting to hit, if that makes sense.
Yeah.
So, I'll pick your brain on HPA for a minute because it's a good topic. We find that that's very tricky because if you change the resource that HPA is scaling on, it can have strange effects. And I'm not sure if you've seen that out there, but we've seen that.
I've heard the story. So I think HPA and VPA, I think I've heard quite a few interesting stories. I think the most interesting ones, at least for me, usually my audience is people getting started or having problems. So I don't have the same sort of exposure that you have. But the interesting thing is that, because of a changing size of things, then you end up in a situation where some pods are bigger than others. It's very, very difficult to understand why, maybe one of these pods is actually running okay, but the others don't. And you get this sort of scenario to the extreme with the VPA, right? You could have like one instance okay, the others are just too big or too small, and then you don't really understand why one is struggling and the other one is not. And then you try to delete the pod and it comes back and everything is fine. And you go and you move on to, to something else, and then the issue comes back. So very, very difficult to debug.
In some cases, we see they're all kind of pretty even load because they all have the same requested limit. So you can set a requested limit that works for all of them quite nicely. Sometimes there's a big skew where the top ones are way busier than the least busy ones. And we model this as well and show it in our UI. And that's tricky because if I set the resources for the busiest one, I've got a ton of stranded capacity. Like we've seen cases where there'd be like 1,000 CPUs stranded in these things because the least busy ones aren't doing much at all, and the busiest ones are doing a ton. It becomes very tricky if there's asymmetric loads in these things, as opposed to them being even. So that's a kind of almost a policy decision of, well, what do you want to size it to? Because if you size it to the busiest, that's expensive, right? So, and it becomes a quality of service discussion. So, HPA is very powerful, but I think there's like you said, there's a variation in the configuration, but also the variation in the load. If the load is highly variable, they're hard to make efficient and be safe at the same time. What we see, but obviously it's a crucial technology. Like I'm not anti-HPA. It's just you need to make sure that you optimize them very carefully because there's this huge amplifier effect. Anything you do on, an requested limit on a highly scaled group just multiplies the savings or the risk by hundreds. Great area for optimization and for risk reduction.
It looks very simple from the outside, just like request and limits. You just set the HPA, you're ready to go. But you say, the implications of that are far-reaching.
And you mentioned VPA, which is obviously the companion topic to HPA. And what are your thoughts on VPA as far as using it for setting requests and limits? Have you had much experience with that?
I had the opportunity to write a white paper on the VPA in production. So I had the opportunity to play with it and sort of explore what it is good for and what is less good. When I started writing the white paper, I sort of realized that my perception was the VPA is actually a good idea. It's a good idea because it's actually giving me some sort of numbers, which otherwise I would have to guess on what are the requests and limits. It has also got a mechanism to update these values dynamically. On paper, it sounds very appealing. But when I started looking into the VPA and just breaking down what kind of things I could apply the VPA for, then things started to getting a little bit more tricky. Because, I tried to map that and sort of I had like this flow chart and I said, okay, what if I use a VPA on a cron job or a job? Well, doesn't have enough time to collect any of the metrics, so probably I don't want to use it because if it collects metrics, too short or too big, then it's going to make wrong decisions. So okay, maybe not a cron job or job. Then I had a look at sort of what else? Daemon sets. Well, okay, it's going to look at the daemon sets, but generally in daemon sets, we run, sort of crucial tooling that we don't want to restart or resize all the time too frequently. Like, for example, you're running ambient mesh from Istio, or you're running some sort of components which is dispatching logs. Yes, I want to get the right requests and limits, but I don't want to restart this very frequently because it's going to break the connection to the other pods. And then, you move on, you go to stateful sets, you sort of don't want to restart databases, you move on, you look at HPA, and the combination of the two is just very problematic. And then you move on, you start mapping all of those and you say, okay, when do I use the VPA then? Right? I think the tool is good, but it's just like, the way you need to think about it is more complex than just enabling the tool and hoping for the best. You actually need to understand what is going to happen in all of these scenarios and how you're going to basically work around them. And I think in that sense, VPA, it is good, but extremely limited. So, if I compare VPA is, by the way, is the only tool which I think is open source and does the same thing as Densify or other products. And I think it is very limited. There is nothing else on the market, open source market. It's still the best we've got, but it's very, very, the utilization for VPA, I think, is very, very, very narrow at this point in time.
Yeah, we don't see a lot of people using it. We have customers a couple that are using it, and they're saying, well, can we be the recommender for VPA? Which kind of makes sense because the way I view VPA is the two big complaints are that it conflicts with HPA because it's not smart enough to know that you shouldn't be changing that CPU because that's what the HPA is scaling on. So we've heard horror stories of it, making HPA scale uncontrollably. But the bigger thing, in my opinion, is that it was back to what I said about, be fast to make things bigger, but slow to make them smaller. You want to look at more data to make them smaller. It's only looking at metric server data. So it's got a short-term view of what's happening. So it can probably make things bigger, okay, but I wouldn't trust it to make things smaller, because it doesn't have enough data to know it's safe to make things smaller. So in that sense, it's not particularly useful for the biggest use case, which is, FinOps and saving money. I think that's part of the reason we find it is not that popular because it's dangerous in certain scenarios. And I don't want to criticize it too much. It's just that the paradigm of it using short-term data and it kind of conflicting with HPA, I think kind of combines to say, okay, it's not used that much. Now, we kind of like it in terms of, from our automation strategy, we now have a mutating emission controller, which it's a webhook that will change the requests and limits when pods are restarted, which is great. There's in-place resizing, which lets you change them on the fly, which is really great. And that's what we're integrating to now. And the third one is we can be a recommender for HPA if you're using HPA. And we find those are all great patterns. You really need to make sure you're starting with a very good recommendation based on the right data and the right analysis and the right policies. Otherwise, any automation is going to become kind of dangerous, right? That's kind of our view on it.
I do agree. I think perhaps the reason why I say VPA, the use cases are very narrow. Maybe it is a good first step to understand how you can change things. However, I think the use case is so narrow that the next step, like selecting a better tool, probably a proprietary tool like Densify, is just like around the corner. Because, as soon as you try, you say, okay, it's good, I can see the value, but I've got this, and this problem.
Yep.
It's not helping me. I need something a little bit more. And I don't think there is anything more in the VPA itself to cover that. I think, even in, VPA will probably, I'm not sure if it already does, but it will definitely do in the future, integrate with in-place resizing. I don't think that will be like the killer feature, which is going to say, okay, now I just use the VPA. Like you say, it's the combination of the data, but also the algorithm used to detect and act on the data that's being collected. I think overall, there are several, and this is my perception, I'm not trying to bash on the VPA. I think it's a good tool, but I think it's just limited for what it should be doing when it comes to resizing.
I agree. Again, in our view, it's all about the kind of the analysis behind it. And then the last step is to make it so, which it's capable of. But again, I really like in-place resizing. I think that's kind of a great progression because that just simplifies, especially bumping things up. Certain things do require restart. A lot of things don't. And it's great, for actually implementing the optimization recommendations. We're quite happy that finally went. It's beta now, but it should be GA soon, but it's turned on by default. So we're quite bullish about that. So we talked about VPA, HPA, all these things. And I guess the other one that is, we'd be remiss in not talking about is Karpenter, because we see, that's a great technology that we're seeing in use more and more. What are your thoughts on Karpenter?
People using Karpenter come back with really, really good feedback. They are sort of amazed by what it can do. Just for context, so Karpenter will basically, most of the people that come back, they say, okay, we install Karpenter. So Karpenter is an autoscaler, And the first benefit they get, if they are on AWS, they will basically remove auto-scaling groups, which are quite slow to scale, and then it will create EC2 instances directly. That's already a win for them. And then the other things they will, sort of the feedback that we get is that these sort of nodes are basically optimized for the kind of workloads that is going to be deployed in them. The feedback is sort of this one, which is, in Karpenter, we call this consolidation. Doesn't really fix the problem that we have, right? Which is you still need to, first of all, you still need to choose families for these instance types. That's one problem. The other problem is you still need to define request limits, and you need to get them right. And, we really talked about how getting them right is not just getting them right in one point in time, but getting them right all the times. It is good, but it's also masking some of these issues. Okay. And that's why people are saying, okay, I installed Karpenter and actually, now it's much better. I saved, 20, 30%, whatever number. But in reality, it's like, have you, or are there more problems now? What's your experience, Andrew, with Karpenter?
Well, I would concur with what you're saying on a lot of this stuff. I think it's great technology, and the consolidation in particular is great. We've done tests where when you automate our recommendations, to downsize CPU request, for example, then it doesn't take very long for Karpenter to kick it into a consolidation. With the right pod disruption budget, you'll start saving money. So it's fantastic from making sure that the nodes are aligned with the workloads. It's great. And so, in combination with Densify, it works really nicely, because if you implement or if you automate our recommendations, it does kind of the full stack. But to your point, it doesn't fix the request problem. If all your requests are 10 times too big, Karpenter will just run 10 times too many nodes. That problem just doesn't go away. Garbage in, garbage out. So if everything's wildly oversized, which it usually is, Karpenter will magically run, all the nodes. It's just going to be running way too many of them. And so I think it's a great enabler, because it just means that when you do optimize them and you do automate that, it just makes the savings realize right away. We quite like it. We've webcasted on the benefits of it, but it doesn't solve the request and limit problem, which we've talked our way through this whole podcast, and nothing out there still really solves this problem of sizing the containers properly, which is the input to everything else.
You're absolutely right. And I think Karpenter is a great technology. And to be honest, I'm really excited when AWS decided to release this as an open source project that everyone could contribute on. Really excited to see, AKS bringing this into their offering as well. But at the same time, it's like, okay, we still need instance size. We still need to understand. I think this is the issue. I feel like most of the time people just say, pick the tool, but they don't understand what are the constraints that they're playing with. And, going back to request and limits, and now, instance sizes, and how a Karpenter is going to do consolidation. On the flip side, yes, you have savings. It's not common to find companies having like too frequent rotations or too frequent consolidations, which is a symptom of either being too aggressive or not really modeling the sort of the pods and requests and limits that you got in your cluster. What I would look into someone using Karpenter would just like, okay, it is working, but have you done this and this?
Yep.
And then how you solve this problem?
The problems don't magically go away. And a lot of it goes back to, if you go back to a VMware configuration where there was a strong overcommit model in the hypervisor, where essentially you could just turn up overcommit and share more resources and kind of make some of these problems go away. Not all of them, but you had a kind of a fudge factor that the platform team could use. None of the things we talked about do that in the container level. They're still just working off literal CPU and memory, not virtual CPU and virtual memory. Because the one technology I wanted to ask you about is vCluster coming up. And well, does that solve it? Because that sounds like virtualization or virtual clusters. Does that allow this problem to magically go away? And I think you've had some experience with that as well, right?
So at the beginning of this year, I basically tried to map all the different sort of multi-tenancy technique. You could have sort of multi-tenancy tools you could have in a Kubernetes cluster, and kind of trade-offs they have. So I mapped things as, very light things like Capsule, for example, that they just create like more advanced namespaces in the cluster, and they offer soft isolation, to more advanced isolation like vCluster, and some isolations like, separate clusters and multiple clusters. So I think vCluster has got a sweet spot, because it's basically running nested clusters in your cluster, and it is able to isolate CRDs, which is most of the time a problem. The easiest solution for that, if you consider your options, definitely something that you would consider for your tools. But the issue is that vCluster will basically run control plane as a pod inside the cluster, and each tenant gets his own control plane. when you create a pod, this pod is created in the tenant control plane, and then there will be a mechanism where this pod is synced between the tenant to the host cluster. But all the problems that you have in a normal cluster will also be present in vCluster, because at the end of the day, vCluster is just a single cluster. So while it is good and many clients are switching to vCluster, I don't necessarily think they're switching because of requests and limits, but more because of they need some way to segregate teams and to isolate them. And they don't want to go the route of creating one cluster for each client, for each team. And they don't want to go the route of, soft isolation, because, there will be clashes on CRDs or things like that. So they find a sort of sweet spot. But yeah, I don't think there is anything out of the box on vCluster that will just, automatically make these requests and limits go away.
It's not a virtualization technology in terms of virtualizing resources. It's a virtualization technology in terms of isolation. And like you said, it's probably great for that, to be able to set up isolation between it. But if everything's twice as big as it needs to be, you'll still end up with twice as much capacity and spend. So, but fascinating technology. Yeah, it seems to be on a good trajectory there.
Yeah, particularly now that, there is all these debate and migration from VMware, finding alternatives on how I'm going to pay the license. So using like a large cluster with vCluster tends to be, from an economic perspective, quite convenient. A lot of the larger firms will probably consider this technology for their clusters.
Makes sense. Well, I think we've kind of explored the gamut of technologies in the time we've had. So hopefully this has been pretty educational. I always love talking to you, and you are in the business of educating. So any parting shots on, from Learn Kubernetes on how people can learn more about all these topics?
Oh, yeah, definitely. So, always happy to share my knowledge. So I generally try to schedule, a few webinars, a webinar a month where I go online and teach core Kubernetes topics. And then we also blog quite a lot. Our articles are generally more researched than just regular blogs. So we're talking about on average between 8 and 10,000 words. So it's just like a book more than an article. But we like to take things to a very low level. We like to go deep and explain how things work. So if you are an engineer that needs to understand Kubernetes because that's, your day-to-day job, then we generally make all of these resources available to you. So definitely check out the blogs. I think the last blog that we did was all about IP tables, and we really dug into, how this stuff is set up in Kubernetes and why it's set up in a certain way. And we've got another article coming up, which is absolutely amazing. And we're basically just looking at how the kubelet collects all of the metrics from container runtime, how it is exposed, and how Prometheus will go and fetch them. So we look at metric servers and all the sort of the pipeline for the metrics. The level of details is it just blew my mind. So I'm really looking forward to that.
That's amazing. And that's very important. Again, there's all these scrape intervals and stuff happening in there.
Exactly.
In our view, understanding what the data is saying, you put a chart up and it looks like, well, that's what it is. But is that what it is? Is that the utilization, or is that the utilization scraped every 5 minutes? Very important topic. This is great and very technical resources, and you clearly know your stuff. So I want to really thank you for joining us today.
Oh, thank you.
I've really enjoyed the chat, and maybe we'll do it again sometime.
Yes, please. Thank you very much for having me.
Thanks.
Andrew Hillier and Daniele Polencic, thank you both. Fantastic discussion. Really appreciated that one. My name is Brian, producer of Densify Talks, and thank you for listening and joining us today. We appreciate you being here. Hope you got a lot out of this episode. Make sure to subscribe to the podcast so that you don't miss out on future episodes as they're coming soon. We'd love to hear from you, by the way. Densify.com. Send us any questions that you have. If you'd like to be on the show or if you have any topic ideas, email us marketing@densify.com. Always love to hear your comments and your thoughts. And thank you very much again for joining us. Have a glorious day. We'll talk to you in the next episode, and we are signing off.